Hi, and welcome to the Anthos Deep Dive session part 2. My name is Dan Ciruli, and I'm a product manager at Google Cloud.
And hi, I'm Tony Pujals. I'm a developer advocate at Google Cloud.
And we're going to walk you through the second part of the deep dive on Anthos. I'm going to start with a little bit of a level set to make sure that you're clear on what the different components are within Anthos and why they exist. And then I'm going to spend some time deep diving on Anthos Service Mesh. And Tony is going to spend some time on Cloud Run for Anthos. But first, Anthos itself. Anthos is an application modernization platform. It's a platform that lets you write applications and run them anywhere, on Google Cloud, in your own premises, or on other clouds, even at the edge in places like retail facilities or warehouses. It's a software-based solution that is aimed at solving the problem of how difficult it is to run things in different places right now. It's there to give you consistency across the different locations you're going to have to deploy in order to make your developers and your operators more efficient at their jobs. One of the key things that Anthos enables you to do is to modernize in place. Moving to the cloud can be hard. Moving from old monolithic architectures to new ones can be hard. And if you try to do both of those things at the same time, well, that's doubly hard. With Anthos, you can modernize your application where you are, still in your data center, if that's where you are, and move to the cloud later as a second step. It's a much easier process to follow. When you do start running applications in multiple locations, Anthos gives you consistency. It lets you do things like write policy about security and have that policy be in effect regardless of where the application is running. This gives your developers, your operators, your security people all consistency to run the application the same way no matter where it's running. One key factor for Anthos is that it is a 100% software-based solution. You don't need to invest in new hardware for Anthos. It runs on your existing hardware. And at its core, it's based on a trio of open source projects. We do container management using Anthos GKE, which is, of course, based on the popular Kubernetes container deployment system. The service mesh component is Anthos Service Mesh, which is based on Istio, the popular open source service mesh. And up at the top, giving your developers a great development experience is Cloud Run for Anthos. We also have a great marketplace for the other things that you might want to run, other software, databases, etc. And around this whole thing, we've got a very good policy management system that lets you manage policy across all the different locations and good operations tools so that the people who are running the software have the same experience regardless of where it's running, on Google Cloud, in your own premises, on other clouds, or at the edge. Now, let me talk a little bit about my favorite component in Anthos, Anthos Service Mesh. And to talk about Anthos Service Mesh, I want to talk about a trend in our industry of moving away from monolithic applications. Why did we decide to move away from monoliths? Well, actually, that second bullet to me is the big one. Monoliths make it slow to innovate. When you have 100 developers working on an application, you're probably deploying that application maybe once a quarter, maybe once every 6 months. It's very difficult to test and release when you're deploying huge applications. They're also very expensive to scale because monoliths tend to run on specialized, very expensive hardware, and buying multiple instances of that can be very expensive. And operation is typically a very difficult process. The move to microservices really addresses a lot of these problems. And again, starting with innovation. With microservices, you have small teams of developers who are each deploying small units of code. Because they can deploy independently, they can ship a lot faster. They can ship features much, much more frequently. That means you end up shipping features to your customers a lot more often. And you can scale them all independently. Microservices are typically deployed in containers. They're running on commodity hardware, and they scale independently. And finally, you've got a great ecosystem of tools around operations that make operating these easy. So what is a service mesh? Well, a service mesh helps you solve some of those issues you'll have as you decompose your application. A service mesh transparently and in a language-independent way adds functionality into your network calls so that your developers don't have to write a bunch of new infrastructure to handle those. It's a core component of Anthos. We offer Anthos Service Mesh. As I said before, this is based on Istio, the most popular service mesh application in open source today. And what does it do specifically? Well, there's three main things that you get from a service mesh. First, it gives you the ability to understand the traffic between your services. Now that your monolith is broken up into microservices, you've got a lot of components communicating with each other. And a service mesh can make sure that you are monitoring, logging, and tracing all of that traffic so you can understand your application. Second, a service mesh gives you advanced networking functionality to make it so you can have operational agility, make it so you can safely roll out new components, do locality-based load balancing if you're running in multiple clusters. And finally, a service mesh lets you secure all of that traffic and ensure that everything is encrypted in transit, and you can write policy to dictate who's allowed to communicate with whom. Today, I'm going to focus on two key areas here in understanding your application and the ability to use some of these advanced networking capabilities. And to do that, we're going to use some chaos engineering and inject a little chaos into our application. Chaos engineering lets you test the resiliency of your application by seeing what happens when different components break. Anthos Service Mesh, in addition to a lot of other things it can do, can allow you to inject chaos. And what I'm going to demonstrate now is how we can inject some chaos to see how our application behaves if one of the components starts running more slowly or if one of the components starts failing. For this demonstration, I'll be using an e-commerce application. It was developed using microservices so we can deploy frequently and independently. As you can see, it's a nice modern application with a bunch of services underneath. Let's look and see what Anthos Service Mesh can do to help us understand this application and how failures might contribute to it. A service mesh is gathering all kinds of information about our application, not just the telemetry that it's being gathered, but the actual topology of the application, which services are communicating with which other services. I can see every service in my application as well as how they relate to every others, including how much traffic they're sending to others. This is some powerful information. And for any of these services, I can dive in and I can understand them even more deeply. Here I'm getting tons of information about my front end of the application. This is the one the users actually hit, so it's the one I care the most about it. As with every other service that's deployed in the mesh, I get great telemetry on it. I can see how much traffic this is serving. I can see things like what its error rates are and how they change over time, as well as what its latencies are. I can do this on many time spans. I can zoom out a little bit and see how it's been performing during the day. One of the great features about Anthos Service Mesh is the ability to set service level objectives. As I said, this is really important, especially on the front end, for me to assess the health of my application. I can see that this application is currently healthy. And I've got an objective here that says a certain percentage, 95% of my requests should be fulfilled within 200 milliseconds. However, earlier today, you can see where I injected a little chaos in the system. And I'm going to show you how I did that. I used Anthos Service Mesh and its use of the Istio APIs to inject a delay in my service. I've got a recommendation service in here. It recommends new products to my customers. And I said 10% of the time, I want you to add a 1 second delay to see what the effect of that would be on the system. The system seems to behave pretty well, but let's look closely again at that service level objective. I can see that I started failing that objective some of the time when I injected that chaos. And if I look at my error budget over this time frame, I can actually see it's going down relatively rapidly. Now, the system isn't telling me that I'm going to run out today, In fact, it thinks I'm going to make it through the day. But this does tell me, as the person running this service, I've got a dependency that that is very critical for me. If the recommendation service were to actually start performing like this, I would be close to, and maybe even would, exceed my SLO and run out of error budget. So what am I going to do? Well, first, I would tell the recommendations team, you should be setting your own SLOs. I need you to be returning faster than 1 second. So I want you to have a stricter SLO than that so you catch your own errors. But second, it tells me that I should make sure that the front end is resilient and, in fact, maybe can time out if the recommendation service takes too long. Anthos Service Mesh can help with that as well. Now I'm going to talk about a different sort of chaos we can inject, and that is failures. As we said before, the service mesh is in telling me exactly how my system is related, how many services comprise it, and how they relate to each other. Here you can see my front end actually talks to a service called the cart service. Now, the cart service is an important service in my application. People can't see what they're buying if they can't put things in the cart. However, if that should fail at some point, I still want the system to be resilient. So I'm going to use Anthos Service Mesh to inject some chaos. I've got a file here called cart error. Again, it's using the open source Istio APIs, and it's saying, hey, in the cart service, I want you 100% of the time to throw a 500. I'm not going to have to redeploy the application, and I'm not going to have to recode the application. I'm just going to tell the service mesh to start returning these errors. I've already made this change, and I have made a commitment. And I can see all I need to do is push this, and it will, or commit this, push it, and it will take effect. So I'm going to inject some chaos here. And then I'm going to push this. Now, my system of record, which is the source code repository, has the new policy. Anthos config management is taking that policy and pushing it into each of my clusters. And as soon as they do, I can see the effects of that policy. So my application is still here and running. And wow, is that a catastrophic failure? Now, again, the shopping cart service is important, but this is not acceptable. This is telling me that I need to be more resilient. So now I'm going to have to go to the front-end application team and make sure that they are resilient to a failure from the shopping cart application. Now, I do want to say, you saw that injecting chaos put some serious breakage in our application. I don't recommend you do this in your production clusters, at least at first. Try this in your dev clusters. Now, I'd like to turn it over to Tony, who's going to talk about Cloud Run for Anthos.
Thanks, Dan. So, Dan just did a really great job of explaining the benefits of microservice architecture and what Anthos does to help you manage these applications that you've deployed. But what can we do to improve that experience for developers? So the metaphor here is I want to be productive in my space. I want to enjoy my space, but I don't want to have to do all the work to create the space and maintain it. So how can Cloud Run for Anthos help us with that? What we see here is that Cloud Run for Anthos is right here at the top of this stack, meaning that it is focused on the developer experience. And what can we do to improve that developer experience? We're going to get to that. Why would you choose Cloud Run for Anthos? In a nutshell, the idea is that you're going to get all the benefits of containerization of your microservice applications, but without the overhead of managing infrastructure and dealing with some of the complexity that Kubernetes introduces when you work at the Kubernetes level for your applications. So looking here, what we see is a spectrum where you can deploy applications directly on-prem as VMs on-prem or in the cloud. And on the far right, we have a fully managed serverless experience. But for whatever reason that your org has chosen Anthos, it's likely because you need to run certain applications that don't fit the serverless model. You've got infrastructure that you do have to manage. But for those applications that could benefit from the serverless approach, you can leverage Cloud Run for Anthos without having to worry about the infrastructure for those applications that you deploy. Cloud Run for Anthos leverages Knative, which is built on top of Kubernetes, And therefore, your operators and everybody in your environment familiar with Kubernetes already gets to leverage that. But from the developer experience, you're going to be able to deploy your applications using a much more simplified model. And I'm going to demonstrate exactly what that means, because I'm going to take the same app that Dan was demonstrating, and I'm going to migrate it to Cloud Run for Anthos.
All right, let's dive in. This is the repo for the microservices demo app that's launched as part of the Anthos sample deployment that Dan used. It's a fairly high fidelity example of a sophisticated microservices application built for a fictional enterprise. It's published as an e-commerce website called Online Boutique. And architecturally, it's composed of 10 microservices that communicate over gRPC, and it's got a data store that we've simulated with Redis, and also we've added a load generator so that we can simulate a bunch of users sending traffic to the public front end. It's typically deployed as a Kubernetes plus Istio application, as Dan previously demonstrated. So what I'm going to show you is how, with just some configuration changes, you can take advantage of a simplified serverless model and seamlessly integrate this with existing workloads running on your Kubernetes clusters. And that's the main point I'm going to be driving here today. So in other words, this demo isn't going to be about all the benefits of serverless per se. There's already a ton of content about that. More importantly, I want to show you how Cloud Run for Anthos makes it easy for your ops teams to provide you with the benefits of serverless coexisting seamlessly in your Kubernetes environments. This will leverage your operators' expertise along with the benefits of using Anthos, our application modernization platform. And so with Cloud Run for Anthos, you're going to get to exploit the best developer deployment model that makes the most sense for each service that you build and deploy. And just to take a look, here are the Kubernetes manifests and the Istio manifests. And so what we're going to do is, what you'll want to do is fork my repo here, Cloud Run for Anthos Labs, and go to this sample right here. And here are all the instructions that are provided. So everything that I'm going to show you can be found in this repo, including a script that you're going to need, that you can use for creating a Kubernetes cluster with GKE. And if you want to create a cluster using the web console, just remember to make sure that you check the box enable Cloud Run for Anthos for the cluster. This line here basically is the part that ensures that our cluster is going to be have the full Cloud Run for Anthos support enabled. Now, I have already done this to save some time, so let's go to our Kubernetes engine dashboard and confirm. I've got cluster 1 here. This is just a Kubernetes cluster running on GKE, and this is what was installed with the cluster with the Cloud Run support enabled. The only services running on it right now, let me sort here by namespace. So within the GKE Connect namespace, what we're going to see is support for Cloud Run error reporting and logging to Stackdriver, control plane component for configuring our cluster local gateway for all the traffic and microservice to microservice internal traffic, as well as our public ingress to the cluster. And these last 4 services are all required to provide that serverless foundation on top of Kubernetes that makes Cloud Run for Anthos work. So now that we've got our cluster, we're going to want to deploy our application. Let's take a look at the configuration changes that we need to make this work with Cloud Run for Anthos. Quick refresher, here's the architecture of our application once again. I want to point out that the load generator is a long-running service that is intended to send traffic as long as the service is running and until it's terminated. So as a long-running service, this is not a good candidate for running as a serverless app. And therefore, this is going to be deployed as a standard Kubernetes service. So the same thing is true for Redis, which is also not a good candidate for serverless because it requires an attached volume. And this isn't consistent with the goals of running as a Knative service under the hood for autoscaling purposes. It's not a good fit for the serverless model. So this is a long-running service, and this is a stateful service. These are both going to be deployed as normal Kubernetes deployments. The rest of these will be deployed as serverless apps. So what we're going to look at is the delta between the original Kubernetes manifest in this repo and the manifest that I have added for you in this repo under the Knative directory. And what I'm going to do actually is I'm going to switch over to my editor because I want to give you a little bit of an overview about what changes before I actually drill into the details. So for one thing, Knative offers a simplified configuration abstraction. There's a single service here compared to the need for two different configurations, a service and a deployment under Kubernetes. And because of that, you don't need all of these selectors and labels to correlate the two configurations. You also don't need to predetermine the number of replicas you're going to need in anticipation of load and availability requirements. You can take advantage of the fact that Knative provides auto scaling out of the box. You can still configure minimum and maximum limits if you want to, but you don't have to anticipate that load. And if you only have a single container in your service, you don't even need to give the container a name. Minor simplifications, but when you look at all of these in aggregate, what you'll find is that Knative offers a very nice simplified configuration abstraction for your service resources. So now let's dive into the actual configuration in more detail. Here under the Knative v1 directory, let's open up this services YAML file. And actually, the first one that I want to start with, I'll start with the front end, since that's the logical entry point for the application anyway. What we see here, so the front end service is exposed to the internet. It serves the web user interface, and it communicates with various back end services. What you'll see here, obviously, the first two lines declaring that this is a service resource using the Knative serving API. We've provided a name and metadata. That name needs to be unique within the namespace. There's no namespace that we specified here, so the default is default. There's only one container provided here. We only need one container for this service, so there is no name for it. The front end service expects environment variables with DNS name : port values be set for each of the back end services that it will send requests to. So note also that all of these services are in the default namespace as well, as indicated by their DNS names. The Kubernetes compute resource requirements for the container are specified here, and at least 10% of a vCPU, limited to 20%, and at least 64 megabytes to start with, and a limit of double that. Since the front-end service listens on the port identified at runtime with the port environment variable that is automatically set by Knative, there's no need to specify a container port value here, as some of the other services will, that we'll see in a moment. The default for the port is 8080, but it's a good practice for a Knative service to get the value of that port environment variable anyway, which this app does. So now that we've covered that, let's move on. Let's go to the ad service. So the front end fetches short text advertisements to display from ad service by sending a list of important keywords from the current page describing context. And there's important things to note here, just two things. In addition to the name, there is metadata that is used to configure the service's visibility as cluster local. And this means that there's no public access to the ad service. It's a private cluster local only service that is accessible from within the cluster. The container port is set to 8080, and although that's actually the default, because we need to provide this, and I'll explain this in a moment, we got to provide the full configuration. So we do have to specify container port. The reason why we're providing name is this is a specific name that indicates that we're going to be communicating with gRPC, or technically this is HTTP 2 over TCP. That's what the H2C stands for. If this isn't provided, then the default under Knative would be HTTP 1. Let's see, moving on, cart service. Okay, so this provides the shopping cart functionality for the app. The configuration should start looking pretty familiar by now. There's only a couple things we need to note here. The app does take a port option, this -P, and we get the value from the port environment variable that's set by Knative. It's listening on 8080, and again, this is a gRPC service, HTTP 2 over TCP. A couple of other environment variables getting set here, and and basically that's it. And let's see, checkout service. Checkout service is used to purchase items that the customer has added to their cart, and like the front end and the cart service that we just saw, the checkout service uses environment variables to get the addresses to use for its backends that it communicates with, and that's it here. Currency service is used to convert currencies to display price, and here we can see that it actually listens on a specific port 7000, so this would need to be specified anyway, even if we weren't using gRPC, which we are. Email service sends ordering and payment confirmation after a purchase. And it's already been mentioned, but the only reason, again, for this specific port, even though it's a default, is because, again, this is a gRPC. All of these services are going to be gRPC except for the front end. Cover the front end. Payment service is used to make purchases at checkout. There's nothing really new to explain about this. Product catalog service is used to convert currencies when displaying price. And again, this should look familiar. Nothing new to explain here. Recommendation service is used to make similar product recommendations while browsing, and nothing new to explain here. And the shipping service, which is used to purchase products, which is used to ship your purchased products. And there's nothing new to explain there. So this is all we had to do to take our Kubernetes manifest. It was basically about what we stripped out. Did have to add some things. We had to add labels that constrained our visibility, and had to provide these hints as to the type of traffic that we want. And that's it. So now let's just take a look at deploying the app. I'll go ahead and start up a couple of watches for our Kubernetes deployment, and also run the K-service resource that just gives us another perspective on deploying these services. I'll want to deploy our backend for Redis, remembering that this was a stateful service with a volume attached, so this is just a normal Kubernetes deployment. And then I'm going to deploy the app itself. And for now, I'm going to deploy the second version of the app. Go to the repo, check out the lab to see what it means to have scaling to 0 configured and what it means for auto scaling up in the V3 version. But this will just be the V2 version where I've set minimum scale to 1 so that the services never actually scale to 0. Because for these services for the website, we're going to expect a responsive user interface. So this is a nice thing to be able to do, but scaling to 0 is normally the default. That's also great for services that don't need to run all the time and consume compute resources for which you're getting billed. Now that the app is running, I can curl it. So let's see, to do that, I'm going to need to know the gateway IP. It's in the GKE system namespace for Istio ingress, and there's the IP. I'll also need to know the DNS name for the route, for the front end. And what we'll see here is actually by default, the domain would have been example.com. I already provided a custom mapping, just another configuration that you apply. I took this basic template and I configured it for a domain that I control, TonyPujals.com. So that's what we're seeing right there. If I curl it, this request is going to go to the ingress gateway, and it needs to know which service to send it. And so with curl, I'm going to do that by providing a host header. It's our front end service and the default namespace. It would by default be example.com, but in this case, since I provided a custom domain mapping, it's TonyPujals.com. And here is the IP that we're going to send that to. There you go. We can see that a page responded. We can also do this in the browser. Now, if I send it to the IP address, obviously I can't send it to example.com since that's not my domain. I can't configure records for it. If I send it to the IP address, I need to do something similar like we just did here when we curled it. I need to supply that host header. So you can use the mod header Chrome extension, specify your host header, apply some filter patterns so it doesn't apply to every other website that you go to. And there you go. This is great for local testing until you go through the trouble of actually configuring that custom domain. But you can test. I can also, since I did configure it for my domain, I can also take advantage of the automatic certificate for HTTPS support. And there you go. I'm at the top level, TonyPujals.com. Here's the application. If you've never seen it before, it's a simple online shopping experience for each one of these items. I can drill in. I can see that the recommendation service is providing other products that are similar. I can see ads. If I refresh this page, some stuff will update. Add stuff to the cart. Place your order. Off you go. Last thing I want to do real quick is I want to go over to the Cloud Run dashboard in our console. There's all the services running for each one of these services. You can get access to its performance, the resources it's consuming, take a look at logs, even go over directly to the Stackdriver page under Ops Logging Console and get access to a ton of information about how things are doing, as well as take a look again at the logs, but with control over how you want to filter, what you want to know. Let's see my container logs, which are in the default namespace for my main containers. And maybe I want to watch some streaming. Okay, so let's go back here to the repo. This is where you want to go. There's the lab. These are all the steps to be able to get through this lab. including checking out all the auto-scaling stuff that I didn't demonstrate, scaling to 0 and scaling up, and then finally cleaning up when you're all done. I hope what I did demonstrate, though, is that with Cloud Run for Anthos, you can definitely take advantage of your Kubernetes knowledge, your existing Kubernetes clusters, and seamlessly coexist with your Kubernetes workloads. And that, to me, is the biggest value proposition of Cloud Run for Anthos, that and the fact that your developers get to exploit the serverless programming model that will accelerate their development. So thanks a lot, and back to you, Dan.
Thanks, Tony. That was amazing. I bet after watching 2 of these deep dives, you're ready to try Anthos for yourself. Great news. We're ready for you to try that. Just go to goo.gle/tryanthos. That's goo.goal/tryanthos. And we've got a fully hosted hands-on trial. It'll spin up a cluster where you can experiment with all of these features yourselves. Thanks very much for your time.